Okie dokie. Hopefully this thing should work now. Hello, chat. I have a new microphone stand. It looks like it should be recording and stuff. Cool. So yeah, I have a exam in like 4 days on a course which I decided I'm just not gonna do. But instead, I'm gonna spend some time doing some old exam questions for the math course I got coming up in May. Or I'm gonna do the exam um, around Easter time. And so, in some sense, it doesn't make any fucking sense to do this now, right? But um, I've decided to do it this way regardless, mostly because I felt like I wanted to do something productive now, but I didn't want to get started on the robot thing at the moment. Check. Can I just see my email from here? I think I removed the email app from my iPad. I think this thing isn't logged in. No, it's not. Okay. Let me just spend 1 second looking at. Oh no, they still have not replied, which is unfortunate. Yeah, because so I've taken 2 courses this. Well, it's not a semester. Right? The semester is the 2, so a quarter. This quarter, I should say. One was this math course, which I originally thought I needed to take, but then it turned out I didn't really need to take it for, in order to get my exam or to get my degree. Right. Oh, fucking hell. Oh, no. And then I took a project course for in preparation for my master's physics project, right? And so I ended up very half-heartedly. I went to most of the lectures in the math course. I did the projects and the laboratories and things, but I at no point, well, beyond I think week 3, I think week 2 or 3, I stopped doing the exercises and just focused on the other course and like you know spending time with my new girlfriend and things, and just trying to, because last quarter was very intense, right? There was constantly things to do, and I struggled a bit. So it's fine, but I am a little bit annoyed at myself. But I've tried to be less annoyed at myself um, as time goes on. So in order to wait, is my pen fucking dead? Oh lord. Let me see here. Yes, my pen is dead. I don't want to just. I'm trying to see, chat, if I have. If I want to be writing on paper instead. Well, I don't think I have any super close by at the moment. I'm just gonna keep talking for a little bit whilst that thing is just charging up ever so slightly. Um. So yeah, in order to pass, I need to obviously do my master's thesis, and I also need to pass one final exam in continuous. Is it called continuous systems in English? No, that's a different name in English. Continuous name in Swedish is FMAN55. What is the English name of this course? Is it just called applied mathematics, or is this where it's given? So if I click this button here real quick, it's just called applied mathematics. Okay, yeah. So I need to pass this course in applied mathematics, which I have retaken it twice, I think, if I remember correctly. The first time when I originally took the course, my grandpa died um, a few days before the exam and stuff, and it was a whole mess, right? So I did excuse my, and I genuinely had a hard time following the course throughout attractions during Corona and such. And then the second time I took it, I just took it with a bunch of other very difficult courses, man. It was just the workload just was a bit much for me at the time. Skill issue primarily, but you know, It was what it was, right? And then like my in some sense my heart wasn't really in it at the time. Right, I was still sort of recovering from the whole everything from life or whatever. And then the first time, the bit before, um, in the weeks leading up to the exam, the week before the exam, if I remember correctly, my girlfriend, my longtime girlfriend, and I broke up. Right, and things were not going great towards the end there anyway. Right, but that was difficult. So the course and I have a bit of a troubled history in that sense. It is genuinely a pretty difficult course, I find. There's a lot of lectures. There's like double the amount of usual the amount of lectures, and along with that, a bunch of like things. What the fuck are they called? Like whatever, where the teacher goes through a bunch of this. There's so much material to really attend. I won't be attending a lot of it. It's not the plan, at least not initially, right? I'm gonna be continuously. Oh, my stand is. I need to make sure it doesn't move around. Initially my plan is just to continuously continue doing all the exams and redoing some exercises from the book as the thing goes. I don't think I need to go through the theory one more time. Really, I just need to first of all I need to read the book somewhat. Right, I started doing that last time around. And it sort of clicked a little bit. I feel like the fact that I have failed the course as many times as I have has like sort of set itself in my own head. When I'm sitting at the exam table, right, like things which aren't difficult become difficult all of a sudden in ways which is very annoying, right? Like I've fucking choked like 2 re-exams as well, right? So I've, in some sense, like I've choked. Holy fucking shit! This microphone stand is ass. Actually, this thing fucking sucks. Holy fuck. Okay, can it stand like this without being terrible, or do I need to? Like, if I do this and then go here, does this sort of work without it falling down too bad? Hopefully. I want it to like be like lifted towards me, but the fucking mic. Well, either that or I need it to be. Well, then I need to flip it. It needs to be above me. Let me try a thing, chat. So if I go here, do this instead, and then we go whatever, and then just flip it like this, and then it's just then the weakest part of it, hopefully, can sort of just be above me like this, and then I can like talk into it. I fucking hate that the light is in my fucking eye, but like this, I don't really notice it. If I did like this, I do. Like a piece of tape or something. This is super annoying. No, that's not a thing you can do. Okay, well, this is the setup, I suppose, for now. This is just what I'm gonna have to do. Do I look stupid on the camera? Yes, I do. I do look fucking ridiculous. Can move it even higher up? No, not really, because here it's starting to affect the. Yeah, because you need to speak into the microphone. All right, and it fucking hits my glasses, so it's like here. So it's just like here. Does this sort of work? It's fine. It's good enough. And that thing is just in my fucking head now. Can't do that. Can I do this? Still in my fucking head. I need a. Okay, wait. There. Do it this way around, and then. Let me just do this mode. Right, it's probably a bit more echoey this way. But now I don't have the fucking light in my face, which is useful. So, okay, let's get into this. How much is this thing charged? Enough. That's for sure. Okay, so I just picked a random exam. Except previously uploaded them to chat for analyzing them and things. So here are a bunch of exams. We're just gonna write here random old exam questions. Like that's fine. All right. So for the new versions of this course, these first types of questions here, which is a answer yes or no, have been removed. So I'm going to ignore basically all of them and just do all the other ones. Because if we go back into the website here and we go where would it be? Is it this one? Yes, and then here are all the exams. Right, if you just take if you just take the newest one, the thing has been replaced. Yeah, bunch of those. Boom, 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 boom. I'm looking forward to redoing this one. I wrote this in late summer. It was very annoying because it's like my brain not function, right? Like if this had come the day before or whatever, it would have just worked out. This is really annoying. That's not one we're doing now. Just arbitrarily, this one was picked. So then April. So it's right here on my iPad. April 2024. Well, okay, let's write April 12th, 2024. Sure. Right. So right now I am basically just going off memory. I've not looked at. I don't even know where the fucking book is. Looking at these old things and just trying to get my brain to see. Oh, do you recognize these things still? And initially, this looks like it would be the temporary. Can I get the I think this is an old one. I think it doesn't contain all the things. Yes, this is the old one, which is a little annoying, but we'll go with it for now, maybe. So here we see that this is a diffusion problem. Number 2 here. So let me just write it down real quick. I'm just gonna write it on the shorter forms. It's ut minus uxx equals 0, 0 x to 1 t greater than 0. Wait, do I have the? Let's check quickly here if I have the or if I have the. Looks like I don't, which is stupid. Because in here, do they have them in the? They don't, right? None of the exams have stapled into the. No, it's just the exam. I think there should be one where it's on there. Maybe not. Maybe I just remember incorrectly. Yes, it looks like I do. Okay. I wanted the formula cheat. Maybe this one. 15 in here. And this was the primary one I used for a while. Yes, here is one. Let's see here if we can download it. No, don't replace it. Oh, fucking hell! My fucking fingers are cold and terrible at writing. That didn't work out. Probably close this thing. It should eventually It doesn't have the thing I'm looking for. Okay, chat. Let me go get it from the canvas page then real quick. How are things looking here, by the way? It looks fine. So let's keep going. This one, I haven't registered for that course. I won't be attending a lot of the lectures, and I'm not required to attend any of the other things. Like there's some computer exercises and things we need to, and I think there's a project even. That course is fucking huge. It's actually so huge. It's kind of crazy. Let's see here. This one. Download. There we go. And if I go all the way down, not here, further down, here. We're gonna use a Fourier series. Yeah. This step here where we replace the function with a sinus or cosinus series. Let's see if I remember correctly. It would be a sinus series if you have Dirichlet boundary conditions. Let's see if I remember that correctly. Just on the top of my dome, right? Just, what's this shit? I don't care. Go away. Where is it? Okay, it's here, and then close this guy, not this guy here. Yeah. So here we have Neumann boundary conditions, right? So then it should be a sinus series, I want to say. Because means there's something still at the edges. If you go pi there, those would be 0. But the derivative of it is not 0, which is fine. I think that's that's like the logic behind it. So let's keep writing here. We have homogeneous Dirichlet conditions. We don't need to homogeneize them. That's not English. Make them homogeneous. Is there a word for that? Like homogeneize? It's close to that. We're getting closer. U of x and 0 is t0. So I have in mind how this solution will sort of look. So here, let me write homogeneous Neumann. I think it's Neumann. Let me Neumann boundary condition. Wait. Is Neumann the wait. Is the okay, wait. So Neumann is versus Dirichlet. Dirichlet specifies a value of a function of the okay, so we have Dirichlet boundary conditions. So this is not Neumann, these are Dirichlet. Homogeneous Dirichlet boundary conditions. Sinus series. Now we're out of the thing for the sinus series, which is over here. This guy there. So we say that u of x of t is assigned as k1 beta k sinus of wait k pi l x. I'm trying to remember here if just I'm writing this correctly. Because if I remember correctly, then this here is the. So this isn't u, this is then like the So this thing here, this is then f of x, if I remember correctly. I think so. I think so. So that's not u of x of t, that's f of x, basically, and u x and t here is of some t of t times, well, now it's f of x, so it's gonna write it as f of x, so big X of x, which is this thing here is then the f, or let's write it like just trying to connect together all the parts here, making sure my brain sort of remembers them a little bit correctly. I think there's a different way to think about this, or a different order sort of thing to do this in. But they also well, it led to the thing, so I'm thinking I'm fine here. But let me just here, right? So now we find our beta case. So our beta case, 2 times L, L is 1, L is the length of the thing. It's 2, 0 to 1. Put in the f of x thing here, which is then t0, wait, so that part is t0. Which this is equal to that. Making sure I'm not doing anything stupid here. Yeah. That is that thing, which is also t. I hope this is correct. Well, we'll see if I'm doing this correctly. Sinus of, well, we can just write k pi x. K pi x. This case here, so this is t0. The function is easy enough. So this is then to t0, and then the so let's see here. When we derive this thing, k pi pops out, so we have a k pi down here, and so a sinus. So we're going to, when we derive the sinus, we get the cosinus, right? But the other way around, right? Take the derivative of that, so it's negative cosinus of k pi x, 0 to 1. So cosinus of k pi, so let's see, here's what k pi is over here, here, and over here from 1. So it's there to there. So it's, let's see, it's 2, 2t0 divided by k pi. And then here we have okay, here, so if k is 1, so this here I think will be k plus 1, and then that's just cosinus of 0, which is 0, would be something like this. Done that correctly, it doesn't look too bad, right? So if k is that thing there, k1, k2, I think that's correct, right? So now if we just put the thing back in here, we have x of t, 0 k1 t of t times 2 t0 divided by k pi of minus 1 k plus 1, something like that, and then the t. So now we've used the, and we've used that, now we use that thing there. So if we let's lose the UXX part, right? So there isn't any x in there. Wait, yes there is. Is that bar? Of course, there's still sinus. Sinus of k pi x in here. So now when you take ut minus uxx, this part here jumps those things out. And disappears, get the negative there, so you get t t prime minus plus then, right? Because the sinus gets derived once, switch then change to negative, and then boom boom. So we get k squared pi squared sure, because and then t and then over here is f of x. Let's call the rest of the things, which should be 0. So we remove all those other things, and then you get t prime of t is equal to k squared pi squared t of t has known solution on form. Let's see here now. So when you derive here, you want those things there to be out. So t of t is now equal to e k squared pi squared t, correct? Now when you derive it, those things jump down, yes. So the answer will be u of x of t to a sum, sum of infinite k's ones e to the power of k2 pi 2 t times 2t0 k pi correct, yeah, minus 1 k plus 1. I hope that little detail there is correct. I didn't spend too much time thinking about it. That's mostly an instinct at the moment. K pi x there. That's my answer. That looks correct. Just that checks the gut. It's mostly correct. I've done these types of things before, so that makes sense in some ways. Let's continue. And it's like a 1 meter long, or a 1 length unit long rod that whatever, 1 length unit long rod that has constant edges, which are kept at a constant temperature of 0. And then the at temperature 0, the rod is T0 across all the things uniformly. And then the temperature is diffused out in the rod. Let's continue here. Number 3. I need to blow my nose, chat. Give me 1 second. Should have muted myself. I'm sorry. Okay, okay, let's see here now. So now we have a different boundary problem in 2D. Delta U 0 on the unit disk x2 less than 1 here. Whoops. U is y squared on the unit square is bigger than 0. We have a line here, 0 between -1 x1, so y is 0. Okay, interesting. So this one is a slight riff on a regular problem, I would say. They made it 2 dimensions, right? That shouldn't really be a problem, but okay. So first of all, let me just draw up. It's my initial feeling looking at this is we should probably do some sort of mirroring thing here. It's probably the easiest way to do this. So first of all, let me just draw like a little circle here. It should even be, that's not a circle, that's an oval. That's the circle. Place it in the middle like here. Sure. And then let's see here. What do we know about this circle? First of all, these two here, these two first conditions. And then the last condition that tells us we should do like an, I think that would result in an even mirroring. I don't remember which way around there, but one of the two. So we know that the second order derivative is 0 inside of this thing. And on the border, let's just add a thing on the border here, I think. Good way of doing that on the, that's not a gray, well, looks like shit. Let me do a circle here then. Entirety of the border here. Duplicate it. Place it on here, and then going to grab my eraser here, and then cut through it like this. That looks fine. Sure. So on here, this is then equal to y squared on the border there. So now we get it on the entirety of the unit circle, and then we can, or wait, this is like a half plane thing. Can we use, we scroll up a bit, for, yeah, for green function. So on the unit circle here, this thing here, or can we use the half plane one? Because think about this here, right? So either way, I think that would need it to be defined on the whole plane, which you can probably mirror it, like in some way around, because you have symmetry on the thing. So you might actually be able to do that. I think it's probably a smarter idea here to mirror it on the opposite side, so to speak. So if we make this thing, let's make this side blue, or maybe that should be red actually. I know you guys can't really see what I'm doing, but you can imagine it. So I don't want to set up a whole thing. Not really feeling that today, unfortunately. And then we're here, here, and then we'll make this side blue. Oh, wait, is it? It's close enough to symmetry that I don't care. And then this side would here be minus y squared. Should be the thing there, I would assume. Due to here, and then let's say do something with this, and then you do a convolution, I want to say, with the Poisson kernel and the function of something. That's where my head is at. Oh, yeah, that's where my head is at least. Let's have a look here. Yeah, it's something like this. Just thing there. Right, so we have a homogeneous green function thing there, right? Into the, so I'm like, I feel like I am in the right ballparkish. So it's 24. It's this thing here. Let me. Does it give any guidance in here? Nå är man villkoret. Kan man då... Oh, we can actually just like change it there too. We can just say fuck your thing. Okay. So if we look at the thing here again. I'm all sick, but it's what it is. All right. We should get which I if my is my idea like really stupid? All right, like I want to check in here. Let's see here if I'm stupid or smart. Yeah. That's sort of where my head is at, right? That's not how. Here we will need to it feels like it would be good to use planar polar coordinates. What are they called in English? I don't remember. Here is a classic transport equation problem with x instead of t, I think. Maybe. I don't know. Jämnspegling. Spegling. So, what are others that are wrong? So, wait, we don't have a Dirichlet condition. It's a Neumann condition. So yeah, we have a Neumann condition. Yeah, so hence. So here we have a Neumann. Condition. Even mirroring. Right, because there you have a discontinuity in the should I call it in the boundary, which we don't want. Or we have we have a discontinuity. Yeah, because when you add those together, but like that. So this here should then be just y squared normal. I hope. So with that, we now define the expanded U thinking about it correctly. So let me just write here real quick, just making sure I don't fuck this part up. So x is then equal to r times cosinus of phi, correct? Y is r times sinus of phi. R is equal to x squared plus y squared. So here, for the other thing there, we have y, so we have our sinus of phi is greater than 0. We have y of r of phi is equal to r squared times sinus squared of phi. That's theta, that's not a phi, that's a theta. That's worth remembering. Let me just make sure here. Anything does not look like that would be the case. Very nice, very nice. Let's see. Yeah, so here. For the problem here, boom, 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 where r is equal to 1 and r and sinus, since we know that that thing is there, is greater than here. Sinus of is positive for the thing there. We also know that's the case for the thing below. So, because we have mirrored it. So this is actually the case for the whole thing. For our problem here, 2 pi. That's not a 2, that's a thing. It's not supposed to be there, it's supposed to be there. So we know that that's true there. For our expanded problem, we can kill this. I hope. Be between this one here and now. Right, that guy's that guy apparently, which wouldn't help us. Okay. Makes like a little bit of sense, I think. Just don't get this fucking answer here, which I think might be the correct answer. That's fair, but let me continue for a bit. I am kind of feeling I want to like a small little walk at some point. So that's what I'm thinking about as well. But let me write things here first, and I might turn the stream off, honestly. I don't know. I am yeah, I don't know. I'm feeling a little restless at the moment. So I'm thinking about it. Certainly. Just turn off now. Let me see here. Just making sure I've understood things here correctly. This thing here is this thing here, which is this thing here. This thing's here. So wait, let me just continue here for a moment. So this here, since we know that r is 1, it's sinus here, which if we check the formula sheet, my throat hurts. Here, is this thing still here? No. Because we know, or no, they use a different form of it, don't they? On here. They use this one here. What they do? I know that's a thing, but I'm trying to remember the derivation of it, right? Because you're using right cos of 2 phi. I know that's a thing. That's one of the things, but I know it's not on this. And then you wait. The original problem is not put in 2 squares. It's not. Go right like that, or we can there. Just k squared, so it like sense. Yeah, sure. Yeah, I don't know, chat. It's been an hour. I think I'm gonna have a bit of a walk around, drink some water and things, and then let's take it from there, I think. But I feel like that's it for now. I intend to do this more often, both stream these things and then some reading some papers and things for the master's thesis, right? I don't know how much I will be streaming in general, but I do intend to stream like sometimes a week if that's possible. That would be kind of cool, right? If I stream once every week on average, that's like 52 streams. Let's say each stream is an hour, and in now an hour, let's say it's on average 2, which it won't be. It will be less than that on average. That's like 100 hours. That's like kind of cool, you know. So that's the plan. That's where I'm at. Thank you guys very much for joining me on this first stream of 2026. It's been fun. I wish I could sit longer here, but my brain is racing and things are what they are. I do hope to do this more often and continue just grinding out exams throughout the first half of this year, and then it's summer, and then hopefully I have like a job and things, and life moves on. So that's where my head's at. Thank you guys very much for watching, and I will see you guys around. Good luck out there, soldier.